In this video, we're going to finish our foldable that shows analysis of each of these three functions. So we're going to first look at our linear function, and we need to graph our points. So with a linear function, it's going to make a nice line, so I don't have to graph every single point. I can just pick the ones on the ends and then draw a straight line through it. That's the easiest way to do it. So I'm going to look at where x is -9 and y is -10. So that would be right here, -9, -10. And then I'll pick the point where x is -3 and y is 8, which is right there. And because I'm drawing a line, I'm going to use a ruler to make sure that everything is nice and straight. That's important. And I'm going to make sure that my graph is taking up, my line is taking up the space of the graph. Okay, so I don't need this left side anymore. I am simply going to look at this right side. So there's some vocabulary that we need to know and in order to apply these concepts. So the word zeros, that's a very specific term. The word zero has to refer to where y is 0. And y is 0 at that value, which is also our x-intercept. Okay, so you got to keep that in mind. So x-intercept and 0 means the same thing, where y is 0. So where is y 0? A lot of students think, well, y is 0 is right here. But if we were to do coordinates all the way across our x-axis is actually the line y equals 0. So my zeros are found everywhere on the y-axis. So our x-intercept is right here. So that there is my 0. And unfortunately, we have to figure this one out because it's not at a nice place and we can't just guess. So our equation, we're going to go ahead, I'll write down the slope-intercept form for this line, which is y equals 3x plus 17. So we're going to solve for the 0. So that's where my y is 0. So that would mean y is equal to 3x plus 17. I'm going to solve for x. So let's subtract 17. So that gives me -17 is equal to 3x, divide both sides by 3. So my 0 is where x equals -17 thirds. So I'm going to write that right here. My 0 is where x is equal to -17 thirds. I could also write that as a coordinate, -17 thirds, comma, 0. So showing my 0, I could do that two different ways. So now when we talk about domain, with domain, I am talking about my x values or input. So this here is my input. It's also my x values. Notice I didn't say x coordinates, I said x values. So all values of input. So when I'm looking at my xy coordinate, where do I look to get my x values? I look at my x-axis. So I'm going to take a ruler and I'm going to make sure that my ruler is always touching the x-axis. So notice that when I slide from left to right, I'm always touching my x-axis. So for example, right here at this place, if I were to look at this point here, the value of x right here is at -8. The value of x right here is at -4. So notice when I'm looking for my x values, I am looking to my x-axis. So I'm going to start at the furthest left. The furthest left is way over here. We see there's an arrow. So this keeps moving down, which means this keeps moving to the left as far as possible. Way out here, I have a value of x that's at -infinity. So as I'm moving my ruler to the right, I'm still touching the function. Doesn't stop here. Remember, this arrow keeps going up and up and up and up and up and up. And so this keeps giving me x values all the way. So that means that my domain starts at -infinity and it goes all the way to +infinity. This is what's called interval notation, and this means this is the same as all real numbers. This is true for all linear equations. So let's look at range. So with range, that means I'm looking for my output, also known as my y values. Notice I said values and not coordinates. So where do I look for my y values? I look at the y-axis, which means that I'm going to put my ruler so that it's always touching my y-axis. So it has to touch my function. I'm going to start at the bottom, and you can see that way down here I'm touching my function. Remember, this keeps going down and down and down, so my ruler would go down and down forever. So that means I'm actually starting where y is -infinity. It's stuck on the paper. And it's touching the function, and it keeps touching the function, and it keeps going. It doesn't stop here, because this arrow tells me that my function keeps going. So I keep having values of y that keep going up to infinity. So again, that means that my lowest value of y is -infinity, and my highest value of y is +infinity. So it's also all real numbers. Okay? This is always true for a linear function, that your domain and range will always be that. So increasing and decreasing interval, what we're thinking about for these is the value of x. So what I'm thinking here is what values of x make the function increase. I'm just going to use that for notation because we don't have much space here. And for here, this would be what values of x make the function decrease or go down. So we're always going to be thinking left to right, left to right. Okay? You can also think of this as positive slope, negative slope. So when I'm looking here, I can see as I'm going left to right, I'm always going in a positive direction. So I don't have a decreasing interval at all. So for decreasing interval, I'm going to write none. There is no decreasing. For this line, it has always increasing. And remember, I'm looking for my x values. So if I'm looking for my x values, my ruler always touches the x-axis. So I'm always increasing from -infinity. Remember, it doesn't stop there because this function keeps going up. So it keeps going all the way to +infinity. So my increasing interval is from -infinity to positive infinity. This is not domain. This is something different. It just happens to be the same. Okay, so let's go ahead and take these concepts. I'm not going to be writing all these words like I did here. This is just to let you know what each thing means, so you have to keep that in mind. So let's look down at our quadratic function. Quadratic, if you notice, is curved. So we have to do more than 2 points. In fact, we should probably plot all of the points that were given because it's curved. So let's go ahead and do -6 and 5. -6 and 5 is here. -5 and 0 is here. -4 and -3 is here. -3 and -4 is here. -2 and -3 is here. So we see this is our nice in between, so I know that this here is actually the bottom of my bowl in my parabola. -1, 0 is here. 0, 5 is here. So just make sure that this is curved. Just do the best you can to curve through the points. You can see I missed my y-intercept. And it makes for a nice bowl. Okay? It's not a V, it's a bowl. So let's look at our zeros. So remember, our zeros are our x-intercepts. So right here, there's a 0 and there's a 0. On here we have 2 of them. So we're going to write them as points. So I have a 0 at -5, 0, and I have one at -1, 0. Actually, I'm also going to write this as x equals -5 and x equals -1. Those are my zeros. So vertex, that's another vocabulary word. I haven't really talked about that. Right here, that's my vertex. So vertex is also a point. The vertex is where the top or the bottom of the curve, and this one here has a bottom curve, and that's at the point. This is an actual point, so I'm going to write the word point. So that's at the point where x is -3 and y is -4. Okay, so let's talk about domain. Remember, domain is my x values. I put my ruler so it's always touching my x-axis. Okay, so my x does not start right here. Remember, this keeps going up and up and up, so it actually curves way over somewhere over here forever. So my x values actually start where I can't see it on the graph. So it actually starts at -infinity if I were to continue this up, and it keeps going. Notice it's touching the function, touching the function, touching the function, touching the function, touching the function. It doesn't stop there. It keeps going because this function keeps going up. So that means that I keep having x values, so it keeps going up. So that means my domain is from -infinity to +infinity. That is also all real numbers. So for a quadratic, this will always be true for domain. What we have to worry about and watch closely is our range. Our range is what might give us a little bit of a challenge. So I'm going to put that little asterisk there. So remember, we're going to go from bottom to top. So right down here, I want to touch my y-axis with my ruler as I slide it because I'm looking for my y values. So as I go up, I'm not touching the function, so I don't have any y values yet. I don't have any y values until I get to the vertex. And that vertex starts at -4. So my range starts at -4, and I'm going to put that little box there to means it includes it. And as I go up, I'm touching the function. I keep touching the function. There's no gaps or anything, and it keeps going up forever. So that means that my y value goes up forever. So this goes all the way to infinity. Another way of looking at this is where y is greater than or equal to -4. That's another way of looking at the range. So we have to be a little careful here now about increasing interval and decreasing interval. We actually have both in this example. So remember I said think about it like slope. We technically don't have a slope in a parabola, but we can pretend we do. So if I were to look at this parabola, I can see that from the top to my vertex, looks like I have a negative slope if I were to draw a line. And if I were to go to the other side, it looks like I have a positive slope if I were going to draw a line. So that vertex is separating my increasing and my decreasing interval. So what I'm going to do on the graph is I'm going to, remember I'm looking for my x values, so when I'm looking for my x values, my ruler has to always touch that x-axis as I slide it left to right, because that's where I look for my x values. So that means something special is happening right here at the value where x is -3. So remember, this here has a negative slope. I'm also going down. I ignore that arrow. I'm going down as I'm moving left to right. So that means, actually, I don't think I want to highlight the graph. It'd be too much on there. I'm actually going to put my x-axis down here. And right here, I'm going to write in this value here, which is -3. So on this side, it's coming down. I have a negative slope, so I'm going to put a minus. And on this side, I have a positive slope, so I'm going to put a plus. So way down here, I have -infinity, and way up here, I have positive infinity. And remember, that's my x-axis. I'm only looking at my x values. So that means I'm increasing only in the positive interval. So I'm increasing from -infinity all the way, -3 all the way to infinity. This is not a point. This is telling me interval. From here to here, I'm increasing. I'm decreasing from here to here. So that means I'm decreasing from -infinity all the way to -3. Again, not a point. This is a region of input. So that can get a little confusing. You have to look at the context. Okay? This is a point. This is an interval. Two separate things. Okay, let's look at our last one. Our last one is cubic function. Let's hear it for cubics. So let's go ahead and graph our points. Again, we have to be careful because we have this little swirly thing going on. We just can't put 2 points in. So when I'm looking here, a lot of students are like, well, wait, there's no -26 on here. Correct, there isn't. I know -26 is way down here. I'm just going to put a little reference point down there for that point. It's somewhere way down here off my graph. Then I have 0, -7. Then I have 1, 0. Then I have 2, 1. And then I have 3, 2. And then I have 4, 9. And then I have 5, 28. So I have something way up there. It gets very steep. So this is not a straight line. This is actually, it kind of like, there's a little whoosh thing that goes in there. And it goes something like that. It's a little whoosh. Okay, a little curve in there. So we're just going to kind of approximate that. So the zeros again, x-intercept. So right here, that right there, that is my 0, my x-intercept. So that's where I have the point 1, 0. 0 means y is 0. That's also where x equals 1. Then I'm going to talk about the center. So the center is like a vertex. That's right here. That point right there is my center. And that's the point 2, 1. Okay, so notice this is a point. My center and my vertexes are points, so I'm going to write point there. That's an actual point. Okay, so now with domain, remember I'm looking for my x values. So I'm going to put my ruler so it's always touching my x-axis. So when I'm right here, it looks like it's not touching the function. This is a very skinny function. However, this endpoint eventually makes its way over here. If I go down far enough, this will have an entry of -10. So for this function, it's kind of similar to a line, in that it's always going up and down, and it's always going wider. So that means that my domain, because it's going to be touching, if I stretch this out far enough, that ruler is touching everything. So that means my domain is from -infinity to infinity, which again, this means all real numbers. Okay, now my range is my y value, so I'm going to put my ruler like this. And again, we can easily see this, that this one here is touching the function everywhere, from the very bottom to the very top. So this again is -infinity to infinity, and that's also all real numbers. I meant to do this in red. Okay, so increasing, decreasing interval. So students sometimes get a little confused in here, and sometimes if it's turned enough, you might have an increasing, like a decreasing, increasing, decreasing interval. But in this case, we don't have that big dip. So if I'm just looking at this, if it were a line, from end to end, that looks like a positive slope, yes? So I don't have anything that's decreasing. I'll give you an example. So if we look over here, from here to here my function's increasing. From here to here it's decreasing. From here to here it's increasing. On this one, from here to here it's decreasing. From here to here it's increasing. And from here to here it's decreasing. So that means I have no decreasing at all. There is none. Let me see, I'll use this color. So here there is none. Okay? Only increasing. And remember, I'm looking for my values of x. So my values of x start from -infinity to +infinity. So my increasing interval is from -infinity to +infinity. The entire function is increasing. All values of x make the function increase. So that's what that means. So that's the basics of analyzing a graph.